Anyone who's seen the images from the Hubble or James Webb Space Telescopes will agree that astronomy does some amazing things. With telescopes that detect light across the entire electromagnetic spectrum to huge simulations that recreate the evolution of our universe, astronomy has discovered a lot about how our universe works and how it came to be. And while astronomy is key to answering some of those big questions, it falls into a category of science that has one rather big problem. It's not exactly useful, is it? This is a question that plagues all blue skies research, science that doesn't have an obvious application or definable end goal. When medical doctors or engineers ask for money, it's for a thing. They have a drug or an invention that they're trying to make or discover. Astronomy isn't like medicine or engineering. When we put in a funding proposal for astronomy, it's about gaining new knowledge for the sake of gaining new knowledge. And a lot of people are involved in fields like astronomy. There's a lot of time, money, and effort that goes into these fields with no inherent practical application. It's a reasonable question to ask. So with that question in mind, for the rest of this video, I'm going to talk about three things. Number one, what are the arguments against astronomy and other blue skies research? Number two, what arguments exist in support of keeping going? And then we'll round out the video with number three, what do I think? Should we just pack it all in? Starting with number one, there are many arguments against astronomy, from the very tangible and practical to the more subjective and social arguments. Let's start with the practical, and it doesn't really get much more practical than money. All science is expensive to do. Science is by its very definition working at the cutting edge of human knowledge. It doesn't exactly benefit from the economies of scale. As I alluded to before, some fields have very well-defined products at the end of them, products that may or may not justify the money spent. For astronomy, that's a little harder to quantify. But let's put some figures on that. In the UK, the majority of astronomy funding comes from the UK government through the Science and Technologies Facilities Council, or STFC. In 2023, the STFC budget for astronomy was about £61 million. Around half of that went directly to universities to support scientific research. These research grants pay for everything to do with research. They pay salaries for researchers, they pay for travel costs, equipment, publishing costs, and any other costs associated with doing that research. The rest of that budget goes towards facilities for astronomy. Typically this will be telescopes or supercomputers. That money goes into upgrades, into new facilities, and into the day-to-day operations. On top of that £61 million, STFC also pays for the UK's membership of the European Southern Observatory and the Square Kilometre Array Observatory. Both of these cost around about £30 million per year. And beyond STFC, bodies such as the Royal Astronomical Society, the Royal Society, and the European Research Council all fund astronomy research in the UK, and there are other sources as well that I've not covered here. Getting numbers for the United States is a little trickier because it's more distributed, but just to give you a taste of the money spent, NASA's 24-25 budget is around $24 billion. Obviously, not all of that is going on astronomy research, but the James Webb Space Telescope alone takes up some $100 million of that in just operational costs. Beyond NASA, there's also money from the National Science Foundation, the National Radio Astronomy Observatory, and a myriad of other bodies throughout the United States. Suffice it to say, a lot of money goes into astronomy. Critics of blue skies research, and astronomy in particular, say that money could be better spent elsewhere. For the UK, normally the example is the National Health Service, where the £61 million block STFC grant could pay the annual salaries of around 1,000 junior doctors. On top of all the money spent, we should also consider the people. Now, getting a good estimate for how many astronomers there are in the world is tricky, but some estimates put the number between about 30 and 50,000. That is 30 to 50,000 people worldwide with advanced degrees in physics, most of them having PhDs in astrophysics or related fields. These people are highly educated, highly intelligent, and will be highly qualified in areas including data science and data analysis. Some will have practical lab experience, having worked on astronomy instrumentation. Others will have extensive experience in computer programming and software development, with some having worked extensively on computational fluid dynamics, machine learning, and artificial intelligence. On top of all that knowledge, many professional astronomers take on teaching roles within their universities and are very accomplished teachers. Most of them will be teaching specialised astrophysics courses, though some will teach more generally applicable physics modules, such as fluid mechanics. Beyond the monetary cost of astronomy, some critics argue the sheer amount of human intelligence and excellence that is spent in fields like astronomy is a waste. That rather than staring into space, quite literally, those minds and all of that effort could be better spent doing engineering or data science or teaching the next generation, rather than writing papers on cosmic dust or star formation. But arguments made about money and manpower are more a matter of philosophy. You can make most of those arguments about any number of fields. So let's discuss something even more concrete. The sheer amount of concrete and other environmentally damaging materials and practices that are associated with astronomy. Yeah, astronomy has a rather astronomical carbon footprint, which is probably a little bit counterintuitive. It is just looking at space. That feels fairly harmless. Unfortunately, as discussed in a Nature paper from 2022, astronomy isn't quite as environmentally friendly as we might like. According to the authors of this paper, worldwide astronomy research contributes around 1.2 million tonnes of CO2 equivalent emissions every year, roughly equal to the emissions of the country of Sierra Leone. Now, I'm not entirely convinced by all of the methods in this paper, for various reasons. They use money as a proxy for direct measurement of emissions a lot, but suffice to say, it's a lot of emissions for a community of academics that wouldn't even fill the Principality Stadium in Cardiff. Because astronomy involves a lot of building ground-based telescopes, a lot of launching telescopes into space, a lot of international travel for both conferences and telescope visits, and increasingly more and more computer power to process the insane amounts of data taken from observatories and to run ever more complex simulations, we have a rather large carbon footprint. In a world where we're rapidly trying to decarbonise, there are those who say the only way for astronomy to become sustainable is to drastically reduce its activities, stop building more telescopes, and move to only the most computationally efficient computing techniques. But it's not just the tangible drawbacks to astronomy we have to consider. While the mere act of doing astronomy, doing stargazing, is fairly uncontroversial, the field has had a number of fairly major points of conflict with the indigenous peoples who live in areas which are objectively amazing for astronomy. Perhaps the best example of this is in Hawaii. The Mauna Kea volcano in Hawaii is a brilliant site for astronomy. It's in the middle of the Pacific Ocean, so the atmosphere isn't all whipped up by terrain nearby, and it's really tall, enough to get above a lot of clouds and into drier air that's easier to observe through. It is entirely understandable from an objective perspective why astronomers want to put telescopes there. However, Mauna Kea is also sacred to many native Hawaiians, and unfortunately, the process of allocating that land for astronomy has been less than consensual, with many protests and legal challenges from native Hawaiians over the years who just want to protect their sacred mountaintop. After years of opposition to the proposed 30-metre telescope, progress is now being made, and the management of Mauna Kea is transitioning to a group that includes all parties, including native Hawaiians. But it has been a long road to get here. And we've got to ask, are better images of the universe and more science really worth all the hurt caused to indigenous peoples, or should we just leave these sites alone under the stewardship of their local communities? Listening to all of that, it may seem entirely reasonable to say that given the financial cost, the number of people involved, the impact on the environment, and the impact on indigenous peoples, should we even continue with astronomy? What has astronomy ever done for us? But that's the thing. Astronomy and blue skies research more generally has done a lot for us. Some of the most important technologies of modern life can be traced back to astronomy. One of the best examples of this is Wi-Fi, probably something you're using right now. Wi-Fi and other wireless technologies like them owe their existence to radio astronomers trying to get better resolution from their telescopes by combining multiple antennae into one larger telescope, a process called interferometry. The problem with this method is that light from distant stars will get to different radio telescopes at very slightly different times, and astronomers needed a way to recombine all of those different signals to create an image. The techniques developed for combining those signals for radio astronomy were later incorporated into the technology behind Wi-Fi, where reflected and interfered with signals from routers and devices arrive at their destination at very slightly different times, where they need to be interpreted correctly so that I can tell you about the successes of blue skies research. Now, there are a lot more examples I could go through, including radiative transfer techniques being used to kill airborne COVID, X-ray detectors being used for airport security, general relativity underpinning GPS, and astronomy coming up with the technology behind CTs, MRIs, and PET scans. But the other major innovation from astronomy that made its way into everyday life is the CCD, the charge-coupled device, also known as the digital camera. CCDs were first developed in the 70s for astronomy, and today they're everywhere, from the James Webb Space Telescope to the smartphone in your pocket. Hell, I'm staring at one right now. And taking a small diversion out of astronomy to the other big blue skies physics, which is particle physics, the internet came from CERN. But you might still be asking, apart from Wi-Fi and cameras and killing COVID and making airports more secure and making sat-navs work and of course underpinning all sorts of medical scanners, what has astronomy ever done for us? Let's talk about the social aspect. Astronomy is often referred to as a gateway science, a science that introduces people to science more generally. And while they might not go into astronomy, it can spark that curiosity that pushes people towards chemistry, biology, medicine, or engineering. Astronomy is also an amazing avenue for engaging the public in science. People like space, it's cool. Just look at the prevalence of science fiction in media. Star Trek and Star Wars are great jumping off points to share real science with the general public who are drawn to astronomy for its ability to tackle the big questions of where do we come from and are we alone? And to address the argument of all those people who do astronomy and could be doing something else, so many astronomy graduates do exactly that. There aren't enough jobs in astronomy for everyone. Astrophysics graduates are really highly educated in scientific techniques and have spent years being taught how to solve complex problems. Many astronomy graduates leave university and go into software development, engineering, finance, teaching, and so many other supposedly more useful fields. So let's come on to that final point. What do I think? Should we just pack it in with astronomy? Now, obviously, I am biased. I'm doing an astrophysics PhD, and I would quite like a job in astronomy at the end of it. But I genuinely think that blue skies research, like astronomy, needs to continue. I'll grant you, we are not a perfect field. Our climate impact is nothing to be proud of, and we need to do more to tackle that. But just because it doesn't have a tangible immediate benefit, doesn't mean it isn't worth doing. And for what it's worth, I think we give back a lot more to society than we take. But let me know what you think. Do you have a different opinion? If you do, or if you don't, why don't you share it in the comment section below or over on our community Discord server. While you do that, let me just thank you very much for making it all the way to the end of this video. This is, I grant you, a little different to what I usually do. Normally I'm just waxing lyrical about how cool space is or sharing my experiences in academia. But I thought this was a question that was worth addressing. If you are looking for something else to watch now, then there is some recommended viewing on screen. Make sure you like the video and subscribe if you haven't already. Hit the bell icon so you don't miss future videos, and I'll see you in the next one.